Hello, this is AMET 104, lecture recording, week 12.1. So today we're going to go over chapter 16.4, and that is expectations. So the concept of expectations is very similar to concept of average, but in this case, it's often called the weighted average. And you'll see why that's the case in a minute. But before we go on to this chapter, in order to understand the concept of expectations, you should actually have a very solid understanding of the percentages and the probability. So without a further ado, let's actually start with an example. So suppose you're in a class and the class is graded upon midterm number 1 and midterm 2. And you also have a homework assignments, and lastly you have final. So let's say this class is graded by this based on this 4 categories. And let's say for the weight, midterm 1 has 20% weight, the same as midterm 2. And let's say for the homework assignments is 25%, and obviously in order to make it 100, the final should be 35. And let's talk about the possible scores. So the possible scores, meaning what each category is graded out of. So in this case, the midterm, let's say, is out of 100, same as midterm 2. And let's say homework assignments were graded out of 200, and that's obviously adding everything up. And let's say the final was also graded out of 200. What about, so let's say for the third row, let's say we put down your scores. So in this class, let's say you received 82 out of 100 for midterm 1, and let's say you received 88 out of 100 for midterm 2, and for the homework assignments you receive 182, and let's say lastly for the final you receive 190 out of 200. So here is the problem. So let's say the professor says that if you receive 90% average or greater, and let's say this is your average. So if your average is 90% or greater, then this implies that you receive an A. So that's pretty simple. And the question here is, did you or did you not receive the grade of A? And how would you find it out? So let's look at a few different arguments that I normally get. And let's say your friend, let's say your friend says that simply because you received 82, 88, 182, 190 for each category, and each category is worth 100, 100, 200, 200, you can simply say, let's say your friend 1 says this. So because you can simply add 82 plus 88 plus 182 plus 190, and since everything is out of 100 plus 100 plus 200 plus 200, simply you can calculate this, and by putting this into calculator you should be able to find that this is 90.33%, which is clearly greater than 90. So hence you should receive an A. But is this a correct way to calculate it? And let's say your friend 2, let's say your second friend, or another friend suggests that since you received 82%, so simply you're converting everything to the percentage, so 82%. And for the second one, you received 88 out of 100, which is 88%. And let's erase this for now for better explanation. And let's say for third one, you received 182 out of 200. And for the final, you received 190 over 200. And since this is 82%, this is 88%, and this is 91%. And lastly, since this is 95%, you can simply add all these up and divide by 4, which in this case you have an 89%. So this is not an A. So each argument from your friends, I mean, they do have valid opinion, but obviously they are suggesting different things. But which is correct? Or are any of your friends correct in this case? So the problem with this is that friend 1 and friend 2, they both really haven't considered the weight of each assignment. Receiving 50%, let's say receiving 80% in, let's say, exam 1, and I mean the midterm 1, is not going to be the same as receiving 80% in the final. It's not going to be the same weight towards the total grade. So how do you actually do that? Because you have to consider this weight. Midterm 1 counts for 20% of the total grade, midterm 2, 20, homework is 25, and final is 35, and that is a really important role. And we're actually going to see how to actually calculate this average properly. So the first thing you do is you have to convert all the scores into percentages, and thankfully your friend 2 has already done so. So express the numerical scores as percentages. And by friend 2, we know that it's 82%, 88%, 91%, and 95%. And now we're going to take care of the weights. And for each weight, you are simply multiply the percentages by their respective weights. So we know that this is 20%. So let's say 20%, so in this case 0.2. 25% is 0.25, and the 35 is 0.35. And make sure you do this in decimal. And simply, we're going to add them all up. So what's going to happen is you take 20% of the weight, or in other words, 0.02, and you're simply multiplying by 82% and add the 20% by 88%, and you continue on. So for the homework is 25% or 0.25 in decimal, and you're multiplying it by the actual percentage you got. And lastly, you have 0.35 multiplied by 95. So if you actually put this in the calculator and see what the number is, you'll actually end up with 90%, which is your correct average. So you actually received an A in this class. Obviously, your first friend who suggested you receive an A, I mean, fortunately got it right, but the calculation was not correct. Your average is not correct. So here, the weight in this average is very important, so we often call this the weighted average. Let's actually do another example that's similar. Let's say example. Let's say at UAlbany, we have freshman, sophomore, junior, and senior. And for average GPA, the freshman has 2.75 and sophomores have 3.08. And let's say juniors have 2.94 and the seniors have 3.15. And this is just the average. So the question here is, what's the average GPA of the entire school? Or is this even enough information that you're given to actually calculate that number? So some of you may argue that you can simply add the 4 and divide it by 4, but that's a very one-dimensional thinking, because as we've seen from the previous example, the weights do matter. So what are the weights here? So in this case, we're not given yet, but the weights here is the number of students for each class. So let's say after some research, you have found out that there are a total of 15,000 students, of which you have 4,800 freshmen. You have 4,200 sophomore, and let's say you have 3,300 juniors, and lastly you have 2,700 seniors. These are all just made up numbers. And so simply put, out of 15,000 students, the 4,800 of them are freshmen, 4,200 of them are sophomore and junior and senior, and so on and so forth. So the weight we can simply find by the ratio of each class. So in this case, we can see that freshman is simply, so the weight freshman is simply 4,800 divided by 15,000, and that is 0.32. In other words, it's a 32% of the entire school is freshmen. For a sophomore, you have 4,200 divided by 15,000, and that's 0.28. For juniors, let's say it's 3,300 divided by 1,500. I'm sorry, 15,000, and that is 0.22, or in other words, 22%. And lastly, the seniors, 2,700 divided by 15,000, and that is 0.18, or 18%. So now we're given the average GPA for each class and the weight of each class. So the overall GPA, so average, I think it's the overall because GPA already implies the average. So overall GPA for the school can be found like this. So you're simply multiplying the weight. So in this case, the for freshmen is 0.32 by their respective numerical value. So in this case, 2.75. And you're adding the 3.08 by the respective weight, in this case, 0.28. And you do the same with the rest too. So 0.22 multiplied by 2.94, and doing 0.18 multiplied by 3.15. And by simply doing some calculation, we can conclude that the average GPA, the overall GPA for this school, is simply 2.9562, or 2.96. So we've looked at two examples in this case, and let's actually do some defining. Let's establish the formula that we have used. So this is the weighted average. It's simply called a weighted average because we're trying to find the average, because that's all you're trying to find, and it is weighted. The different categories weigh different amounts in this total of the average. So let capital X be a variable. That takes the value, let's say small x1, x2, to xn, and let w1, w2, dot, 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 all the way up to wn denote the respective weights for these values. In other words, if you simply add all the weights, this is similar to the probability. it has to be 1. Then the weighted average is given, so weighted average of x is given as such. W1 multiplied by x1. Let me actually redact it to a dot. Plus W2 x2 all the way up to Wn multiplied by xn, and that is how you find the weighted average. So let's actually do a few more examples. So here I know the terminology of and different notations and everything can be quite confusing, but I only wrote that because I wanted to make a formal definition. But simply said, if you're given weight and the numerical value for each weight, you can simply multiply the respective weights for each value and add them all up. And that's how you find the weighted average, simple as that. So suppose you are now taking an exam, let's say SAT or GRE. Oftentimes in these exams, if you, a lot of the problems are, first of all, multiple choices. And oftentimes, if you get it wrong, instead of just not receiving any points, you actually lose some points. And here, we're actually trying to see the expected value, or in other words, the weighted average is the same thing. So let's say you are guessing. You're simply guessing all the multiple choices, and there's only one correct answer out of 5. So let's say outcome you have the correct and you have incorrect. And since there are a total of 5, it means that there are 4 possible incorrect and 1 possible correct. So we can say the probability of getting it correct is because you're not really trying to solve the problem, you're simply guessing everything. So here, the probability will be 0.2 and it'll be 0.8. And I would assume that we all understand why that's the case. It's simply 1 out of 5, 4 out of 5. And let's say now the point payoff is given as, if you get it correct, you get 1 point. But if you choose an incorrect answer, you lose 1/4 of a point. So let's actually find the weighted average. So in other words, you're simply multiplying the point payoff by their respective probability, or in other words, the weight. So simply you can say that it's weighted average is simply given as 0.2 multiplied by 1, and you're adding 0.8 multiplied by negative 0.25, and you can simply see this is 0. So in this case, the weighted average, or in other words, the expected payoff, is 0. In other words, you're not really gaining anything by guessing your answers. So if you're given an exam setting, in this case, if you're trying to simply guess your way out of it, sure, you could. You're not really losing anything, but at the same time, you're not really gaining anything, because the average at the end, if you did this over and over again, because you're also losing a quarter of a point with the probability of 0.8, you are really not gaining anything by simply guessing all your answers. So let's say now, in a different scenario, but obviously in the same sense, instead of given 5 choices, you're given 4. So in this case, you have correct and incorrect, and the probability. Because you're choosing from 4, the probability of getting it correct is 0.25, or in other words, a quarter. And obviously the incorrect is the complement, so it has to be 0.75. So these are the probability that you're getting it correct and incorrect if you're simply guessing your answers in the multiple choice questions with the 4 options. And obviously, let's say the point payoff. In this case, for the correct is 1 point, and for the incorrect, it should be 0.25. So we're taking away a quarter of a point for each incorrect question. So once again, you can simply do the weighted average or the expected payoff. In this case, let me use the terminology expected payoff. And let's say we're just going to say E. So for the correct answers, you have a probability of 0.25, or in other words, the weight of 0.25. And for that value, you're gaining 1 point. So you're simply multiplying the value for that respective weight, and you're adding the 0.75, which is the weight of incorrect, or the probability of getting incorrect answer, and you're multiplying by the point payoff. In this case, it's a negative 0.25. And if you put this into calculator correctly, you should actually end up with 0.0625. So in this case, this tells you that if you simply guess your way through it, if you're simply guessing a question, the expected point gain, point payoff, will be 0.0625. Sure, it's not a huge amount of points that you're getting, but you're also not losing anything. So if in this case, you can simply conclude that, oh, it's not a bad idea to simply go ahead and guess your answers if you don't know how to solve it. Let's do one more. Let's say for the correct probability, you now have 1/3 probability. In other words, now you're choosing out of 3 choices. And let's say now for the incorrect, because you're choosing out of 3 options, you have 2 out of 3 probability of getting it wrong. And let's say the point payoff is 1, and point payoff for the incorrect is -1/4. So the point payoff for the correct answer and the incorrect answer hasn't changed. The only thing that's changed here is the number of choices. We first try the choices of 5, so you're choosing 1 correct answer out of 5. And after then we try the choosing 1 out of 4. Now we're choosing 1 out of 3. The expected payoff, you can simply say it's now 1/3 multiplied by 1 and 2/3 multiplied by -1/4. And the first term is 1/3 and the second term is 1/6. Sorry, it's -1/6. So simply you can say this is 1/6. In other words, you also have a positive expectations. We're actually going to do more examples next class. Next class, we're going to do more examples of weighted average and expectations. But before I let you go today, I'm going to just define expectations. It's simply the same thing as the weighted average. They're just using different, I don't want to say notation. Yes, notation, but it's just a different concept and different wording. However, at the end, it's really trying to find the same thing. In different context, you're using the different word, different terminology is better suited for each each scenario, and that's the only reason why we're defining this separately, but at the end, it's really the same thing. So expectations, which is essentially the same as weighted average. So suppose X is a variable that takes on numerical values. X1, X2, all the way up to Xn with probabilities P1, it's a different terminology, P2, all the way up to P sub n. And obviously, since it's a probability, if you add all the probabilities, probability assignments would add up to be 1. And then the expectation is given as P1 multiplied by X1 plus P2 multiplied by X2 plus ... all the way down to Pn multiplied by Xn. So you're simply multiplying the respective probability for each numerical assignment. And that's all it is. So I think I'm going to end the class here. I think that's all for today. Next class, I'm going to do a few more examples on this chapter. I know this chapter we've only gone over a lot of examples, but I'm going to go over different examples which you may or may not encounter in the future. And yeah, that's it. Guess, yeah, that's it. So thank you for joining the class, and I hope you have a great rest of the day.